Okay, the next topic we have to look at is still lenses, but lenses pertaining to situations involving human eyesight. Okay, human eye is quite amazing, um, and you maybe go into much more detail than we do in physics, but essentially most of the refraction of the light will happen at the retina. Okay, so or sorry, at the cornea at the front here. Okay, so most of the refraction of the light is going to be done there. However, inside the eye, you have a lens that can change its shape so that the light focuses or produces an image on your retina at the back here, which just has little light sensitive cells that change the light into an electrical signal that goes to your brain and allows you to see. So the whole purpose of the eye is really to create a real, inverted, diminished image that's sharply focused on the back of the eye. Now, to simplify things in our diagrams, we don't tend to draw what actually happens, which would be a refraction at the front of the cornea and a refraction in the lens and the eye. We just draw all the refraction happening at the front of the eye. Okay, but just as you're sitting listening to this, if you bring your finger about as close to your eye as you can still focus and still see the fingerprint, there is a point called the near point, which is the closest you can bring an object and still get it into focus. Okay, that is taken to be, and you need to know this for the exam, 25 centimeters. Okay, so for most people, if you bring it close than that, say to 20 or even 10 centimeters away, you won't be able to focus on it. Okay. Likewise, you can move objects further away than that near point, so to 30 centimeters, 40 centimeters, and your eye can adjust to still produce a focused image on the back of your retina. Okay. Now, if we were dealing with just a normal lens like we do in our optics benches, we would have to move the lens as the object gets further away, so it still focuses on the screen. And that's what happens in cameras. Typically, the lens will move backwards and forwards to produce a still focused image. Your eye doesn't do that. Your eye changes the shape of a little lens inside the eye to still produce that focused image on the back of the eye. And for people with perfect vision, they can do that from objects that are 25 centimeters away all up to an infinite distance away. By that we mean you can sharply focus the stars in the sky. Okay, that ability to focus on objects at different distances is called accommodation. Okay, and essentially you just have a little lens inside your eye here, and you have little ciliary muscles. So if you're looking at the front, you have muscles that are kind of shaped in a circle, and when those muscles tighten, okay, it goes from having a big circle to a smaller circle. And the effect of that is on the lens that is in here. So if we draw a lens in different colors, so you have a lens in the middle, is it can squash the lens. And the lens can go from being thin to being thick. Okay, and that's how your eye focuses on objects at different distances. So if you notice from the light coming from this point that is only 25 centimeters away compared to an object that is an infinite distance away, the rays from the object that is nearby will be diverging more when they enter the eye, which means we need to bring them back and converge them onto the retina, which means we need a more powerful lens, a fatter lens here, than we do in the case of when the object is an infinite distance away. Those rays are parallel, we don't need to bend them as much for them to meet on the retina. So, I mean, just practice it. Look at your hand close up, then look at a far away object, hand close up, far away object. Without even thinking about it, you're changing the shape of the lens in your eye. You do it completely and utterly automatically. But that's what you're doing, okay? Now, this is the ideal situation. Not everybody has perfect vision, okay? However, if there's a defect in your vision, we want to use additional lenses, i.e. glasses or contact lenses, to get it back to this point. Okay, so we want to have a near point of 25 centimeters, and we want to have a far point of infinity. And what we're going to look at in the next couple of sections is how we fix in what focal length of a lens we need in each case. Okay.